All right, so today we are going to cover the solution to the ER diagram quiz, and then I'm going to give you guys an opportunity to earn some points. It looks like a few people forgot to turn it in, so it's been over a week. So if you still want to, I haven't heard anything about anyone needing help, so if you haven't done that yet or haven't submitted that yet, it's too late to get full points because I'm about to go over the solution, but you can still go for the makeup points, and it's important for you to understand how to do this, because you'll do it again on the midterm. Okay, so don't blow it off this time. All right, so I went ahead and opened the quiz here, and I think I'm going to use draw.io for the solutions, which you guys can use. What I would like you to do is compare your solution to mine. Okay. If you have the correct answer, you're good. If you don't, I'm going to offer some extra activity for each question so that you can fix it and then get some points for doing the kind of extra activity, and those points will be I guess available for everyone. I'll just make them extra credit points. That way it's fair. Okay. I'm trying to entice you to go back and actually do this because you need to know how to do it to continue, and I figured showing you how I did it would help a lot. So anyway, I might be able to just put this right in here. All right, so the database ER diagram quiz, where you are, this is basically covering the information all the way up right before deciding on the fields for your tables. So we're only going through primary keys. Here we're kind of deconstructing a set of tables into an ER diagram, and here we're just doing the same thing as the beginning. It's just there's more to it. So let's go ahead and start here. So 1, list the entities from the ER diagram. All right. I don't think I need to type that one in. You either know which of these are entities or which are not. So the answer would be teacher, course, and student. And then this one, it's the tricky part. Here is list the entities, so I want you to name them. And then here it just says count the relationships, because a lot of times the relationship names won't make it through to the end design anyway, so they're not quite as important. Thank you. All right, so how many relationships are there? All right, so we have a relationship between teacher and course. Remember, they're the diamonds, and we have one between course and student, so 2. So that would be 2 relationships in this example. And then part 3 wants you to label the relationship types on the ER diagram above, following these rules. All right, so these are the logic rules that you would think about when deciding how to, or which relationships to use. Okay, so the first one says Teachers, let me zoom in here. You probably can't even see this, huh? All right. Hopefully that's easier to see. All right. Okay, so the first relationship is described as teachers can teach many courses, but a course can only be taught by one teacher. Okay, so a teacher can teach many courses, but a course can only be taught by one teacher. So we have the words many and one. So probably going to be a one-to-many relationship, but how do we represent that between teachers and courses? So, probably not going to let me edit in this mode, is it? Okay, darn. So, I'm just going to put them right in on here for this. And in Word, I think you can double click on text box. No, I guess not. I thought that was a shortcut. Anyway, we want a relationship. We're going to put one here. Well, with the one-to-many, we need to decide which side we're putting the one on and which side we're putting the many on based on the logic, which I gave you for this quiz, but you would have to figure out based on how the organization wanted the data to be modeled. So we said a teacher teaches many courses and a course can only be taught by one teacher. All right, so in that case, we need the many side, the one side here, okay? And so that says a course is taught by one teacher. So every course only has one corresponding teacher that teaches it. Not always the case for every organization, but that's what I said this one was, so that's what we had to follow. If you did a different relationship and you did it correctly, because this didn't make sense to you, because you know, a lot of teachers can teach the same course, and teachers teach many courses, and each course can be taught by many different teachers. So, logically it would be a many-to-many, but I specifically wanted to use a one-to-many so that you would have to figure out which side is which. Okay. That's not right. All right, so I'll put the M side here. And one side over here. All right, that's one down. Now we have a student can take many courses and a course can be taken by many students. Well, that makes sense. Wouldn't be a very good school if you could only take one course. And if only each course could contain one student, it wouldn't be very economical. So here we have a many-to-many relationship. So I'm just going to copy this one. And we'll move that over. Here. And many-to-many, remember, uses the MN notation. Alright, so there's our, there is the types of relationships added into the diagram. Right. 4, add primary keys and foreign keys to the ER diagram. Okay, so this part shouldn't have been too difficult. because you just get to come up with the primary keys yourself. I'll just copy this again. We'll throw this over here. So for the teacher, we'll have a primary key of teacher ID. Courses, we can use course ID. Are you noticing a pattern? And students can use student ID as our primary key. All right. Once we've decided our primary keys and our relationship types, all you have to do is follow the steps for deciding on your foreign keys. Okay, and so we have the most common relationships represented in this example, a one-to-many and a many-to-many, which treat or use foreign keys very differently. So let's start with the one-to-many. Okay, so if each course can only have one teacher, but each teacher can teach many courses, then we need to move the primary key into, or copy the primary key from one of the tables or one of the entities as a foreign key in the other. So I did an example in a previous video of what it looks like if you do it either way and how it lines up with the logic, but you can review that if you want. But basically, as a rule of thumb, you just take the primary key from the one side and put it in the many side. Because since a course can only have one teacher, we're just going to store which teacher is teaching the course as a foreign key, its own field in course. So if we look at the data in course, it's going to say the course ID, probably the course name, and to keep track of who's teaching it, we have a teacher ID field, okay? And that it'll have that field in common with teacher. And so if teacher 1 is teaching course 1 and we want to know their name, we just look up in the teacher table the TID of 1 and it will tell us what the name is. All right. Trickiest part of that is remembering which way to move the primary key for a foreign key. All right, now we have a many-to-many, and this is a special case. Remember, we talked about this. There's no more foreign keys over here, primary keys. But over here, we do, and I'm going to move this up here so we can see it better. So we have this so far. And in a many-to-many relationship, do you remember what steps we need to take to properly represent this relationship? We can't move the primary key from one side, so I can't put CID in student or put student ID in course, because this is a many-to-many relationship. A course can have many students, so there would be no way to represent at the same time students in multiple courses and courses with multiple students. We would run into one of those improper fields that we talked about. So for a many-to-many relationship, it actually generates a new table. Okay. Can I use the computer right? I don't know. All right. Oh, come on. This is the fun part about doing it live, right? Okay. So we're going to create a new table, or basically, you know, this relationship now is going to represent its own table. And if you remember, in this case, what will be the primary key and the foreign key? Well, we're going to have one primary key, which actually contains the attributes of both the primary keys in the involved tables. Let me make this so you can see it better here. I think. All right. So remember, what is this called? When you have two values in one primary key, it's called a composite primary key. So it's just a combination of two fields. And the reason we can use these two fields together is none of the records stored in here will have both the same CID and SID at the same time. So the unique value is the combination of those two fields. Okay. In a perfect world where students never need to retake courses, or but we're not worried about that because we didn't talk about that in the example. What is the foreign key in this case? Well, it's actually the same fields again, but it's important to understand the primary key here is over both fields together, while I don't know why it's putting so much space there. Oh well, I won't fight with it. Okay. I have to get my touchpad checked out or something. So we have CID and SID as a foreign key. Okay, so that satisfies the requirements here of add primary keys and foreign keys. Question 5 says, how many tables will be created from the CR diagram? All right, so we know each entity represents a table. Okay, so that's 3. There's 3 entities, so there's 3 tables right there. Are there any additional tables? Well, you have to count many-to-many relationships because they will become a separate table. So 3 plus 1 is 4, so we should have 4 tables created. All right. All right, this one's a little tricky. This one is giving you the completed tables from an ER diagram, and it's asking you to create an ER diagram that could possibly represent this data. And now this isn't, I'm not having you do this to be mean. If you encounter data organized into tables that maybe was improperly designed, or you want to add something to this, it's a good, and you don't have an ER diagram, it's a good idea to generate one so you can make better decisions. Okay. So we have 3 tables. All right, but how do we know the relationships between these 2 tables? Because an ER diagram needs entities and relationships. All right, and then how do we know what are the primary keys and what are the foreign keys? So let's go ahead and we're just going to use draw.io for this. This is 6. Okay. Alright, so I think I can make this better. If I just, let's see if it'll let me copy this into here so we can see it as we go. Alright. Well, kind of worked. Very interesting. No idea what it's, oh, there we go. What it's trying to do here. I guess it's trying to justify the space between the tables. Okay, well, we'll just go from here. So, there's a products table. Well, let's create a products entity for our diagram. Okay, we also have sale and customer. So, sale and customer. Okay, so there are entities, and now we need the relationships because you can't have an ER diagram without relationships. What represents a relationship? You know, it's a diamond shape, but what does it actually become in the finished tables? What did we just do in the last question? Or the last problem here? Right, we added primary keys and we added foreign keys. Why did we bother adding foreign keys to this? And what determined how we placed the foreign keys? It was the relationships, okay? So, the relationships are represented in tables by using foreign keys, which are just fields. Remember, those are the columns. So, for example, in the products table, we have product ID, product name, and price. All right? So we'll need to identify the primary key out of these 3 fields. Probably product ID. That seems like it would be the one that's unique. Sale has quite a few IDs. It has sale ID, product ID, and customer ID. Which one do you think uniquely identifies each sale? Probably sale ID. And customer, probably customer ID. So there's our primary keys. Okay. So products has a primary key. Try moving this out of the way so I can make this bigger for you. So I have a primary key of product ID, and I'm okay if, you know, you want to shorten things like this. Shorten the names, abbreviate them. Whoops, we're not ready for foreign keys yet. So we had primary key of product ID here. What's this? Oh, have product or primary key of sale and primary key of customer ID. All right, so now adjust those. I don't think I made it any bigger for you guys, so I'm sorry. Let's see. I can edit the text on here. It looks like there might be one person watching right now, so if you're watching this recording later, don't forget you can ask me for help if you need it. All right, so we have to go in here, make this a little bigger. And all right, all that just for the first part here of our ER diagram, which is just the entities. Now let's focus on the relationships. Now when you're going backwards, I wanted you guys to try to figure this out if you could, but if you're going backwards from tables to an ER diagram, you're given all of the primary keys and foreign keys, okay? So you're just trying to find them in the tables. So products, well, a foreign key is always going to be a primary key from another table. So all we have to do is find which tables have fields in common and don't, and one of them isn't the primary key. If they were both the primary key, well, no, that could be, technically two tables could have the same field name for primary key, but you'll see when we get into SQL, the way you reference a field uses the table name as well. All right, so looking in products, you know, when you're looking for foreign keys, they're usually, it's something that could potentially be unique in some tables. So for example, product name, that's probably, there's going to be too many cases where that's not unique. Price, obviously not unique. Though product ID here, so sale ID is the primary key of sale, so it's not a foreign key in this case. Product ID is the primary key from products. Okay, so we found one that's linked together. We have product ID in sale and product ID in products. Well, it's the primary key in products, so it's probably the foreign key in sale. So we come up here, we can add that foreign key in. Remember, you can have numerous foreign keys. All right, and then before we put in the relationships, we should identify all the primary keys. And then all we have to do is follow the steps of determining the foreign keys, but backwards. And then we put in the relationships. So I'm going to go a little bit faster here since it's the same process. So we left off with product ID. Quantity, that's probably not going to be a primary key anywhere. Customer ID, that is a primary key here. And so in here, we have another foreign key of CID. All right, so let's just take a look at these tables. We have products, sales, and customers. Okay. Sale has a foreign key of PID, which is the primary key of products. So we know there's going to be a relationship between those two because it was modeled by those foreign keys. And if you're using this, please do take the time to change the line to have no arrow I know it's an extra step at the beginning and it's easy to forget. If you don't do it at the beginning, all your lines will have arrows and you have to go in and manually change them all, maybe. If that happens, I'm going to be pretty lenient about it, but I'm just giving you a heads up of how to fix that. Okay, so those are related. And honestly, we don't even need to give it a the relationship a name for now. It's fine to leave it. Okay, and then where else? So those two are related because of the foreign key. So we have a foreign key here also of customer ID, and that matches here. So that means there's a relationship between these two. So we need another relationship. I'll put this one down here. Okay. Connect this on to here. Okay. And now the last thing to do is to put in the relationship types. And so for each one of these relationships, there's only going to be one relationship that's going to work, at least between one-to-many and many-to-many. Oops. I just want to double check what the direction said here. Okay, create a possible ER diagram, and then it says label the relationship types, primary keys, and foreign keys. So we have everything but the relationship types. Okay, so remember the rules of one-to-many and many-to-many. So in a many-to-many, we have a relationship that becomes a table. You know, working backwards, it's actually kind of hard to identify many-to-many, and I'll show you that here in a second. But in this case, we have two one-to-many relationships, and we can see that because we have the primary key from one side of a relationship added to the other side as a foreign key. So remember, that's how you represent a one-to-many relationship. Which side's the one and which side's the many? Well, you always take the primary key from the one side and put it in the many side. Okay? And then we have the exact same thing on over here. So we are going to take CID and put it in sale. So that means customer. So the customer side has a 1 and the sale side has the many. Okay. And so this would be an acceptable answer for this problem. There is another possible answer, and that is if you noticed in the sale table that it has both the product ID from products and the customer ID from customer, it could represent a many-to-many relationship between those two entities. And so what would that look like? I'll just put it down here. I think I can get rid of this other thing. Okay, so let's move this up out of the way. So I hit Control A just to select everything. That's not right. And so I want to click when I have the four-headed arrow. That represents moving things, at least in Windows. So here I have a two-headed arrow. This is for adjusting the line. I want a four-headed arrow. Okay, so we have that up there. I'm actually just going to manipulate a copy of this one. So I'm going to select all. And we can copy this, Control C, Control V, and now I have a copy. I'll bring it down. Oops, don't do that. So I just undid the placement and then recopied it. Bring it down here. So how would we change this to look like a many-to-many relationship? Well, all we would have to do is change this shape to, seeing if there was an easy way to do it, to a diamond. And this is actually a pattern that you can follow for most structures like this. So an entity that has a one-to-many relationship with two other entities, in this case, and the manys are on the inside and the ones are on the outside, this is just another way to represent a many-to-many relationship. So this is extremely similar. It just depends on how you want to model it. Or sorry, this one gives you the same effect as this one. If you know, we don't need this anymore or this. We will need the product. We'll still need all the tables. We'll just need to represent fewer relationships, but you'll notice, even though we are only going to have two entities in one relationship, we're still going to have three tables. So you can think about why that is for a second. Okay. And I'll just make new lines because I'm not going to adjust all those. Okay. Pull this over here. Pull this, whoops, over here. All right, and so remember, many-to-many is M and N, and I believe those are holdovers from relational algebra, which is what relational databases are based on. All right. So, what would change in this case if we did it this way? Well, we wouldn't need to necessarily keep track of a sale ID in this case, because the combination of, at least the way we've modeled it, PID and CID could be used as a composite primary key. They're still going to remain foreign keys. So we could also model it like this. Either way is acceptable. This way, if you did it this way, I'm very impressed. If you did it this way, I'm still impressed, because I don't think we did a reverse ER diagram from tables. So it must have been easy though, because I didn't get a single question about it. All right, so the last one lists the entities from the ER diagram, so you can just count the rectangle, or I'm sorry, don't count them for this one. Write them in there. Count the relationships, those you can count, and then you can label. It's basically the same as the first one. It just has more entities. And I'm going to see if I just have a picture of it, because I don't, maybe you do, but I'm assuming you don't want to see me do the exact same steps again. If you're able to get the first one, it's the exact same for the second one. Okay. Must not have saved that. Usually do this in class, so I usually do it by hand. Just doing it the way I've written it on the computer is, it's not meant to be done digitally. Okay. So I'm just gonna go crazy on this one, and I'll just do it, and then you can play it in slow-mo if you want more, if you want to hear everything. Okay. So it says, label the relationship types based on these rules. Okay, so customers can purchase many sales. I know the wording on this is weird, but you're focusing on the names of the entities and the words one and many, basically. So each sale has one customer, but a customer can make or purchase things in a sale many times. Okay, you know, if you go to the store, you can go to the store the next day and they'll sell you stuff. But if you're buying like a TV at the store, they're not going to let you and your friend pay for it. One of you is going to have to hand the money over. So they're selling it to one person. So we just need to add that in. So I can just make one and reuse it. And I'm going to remove the outline this time though. There we go. Okay, so a sale can only be made by or purchased by, each sale involves one customer only. There we go. But a customer can come back and buy stuff again. So there's that. All right, the next one is a sale can contain many line items, but each line item is part of only one sale. Okay, so this is like line items on a receipt. So if you remember in the PowerPoint, we looked at that Walmart receipt, and it had a bunch of lines, and each line represented one item being purchased, so that we could see, so you could see the price of that item. All right, so a sale can contain many line items, but each line item is part of only one sale. So it doesn't say it in here, but you can imagine a line item might show you the price of the product, how many were purchased in that sale, and the name. So if I was buying 5 apples in one sale, that record of 5 apples is going to be part of that one sale, is the idea. Okay. I should make more relatable examples, huh? I'm trying to model business, because that's, you know, you would most likely be working with a database in a business setting. Okay, so a line item can only be part of one sale, but a sale can have many line items, because I want to be able to buy apples and bananas at the same time if I want. I don't want to have to pay for the apples, get back in line, and pay for the bananas. All right, next one. Products can be part of many line items, but each line item contains only one product. So on a single line on the receipt only references one item, but you know, if me and Jim want to go both buy apples, no, I'm saying that wrong. Products can be part of, oh, right. So no, I said it right. If we want to buy the same thing, we want to be able to sell different products to different people, or the same products to different people. So a line item contains only one product. So on the receipt, one line represents one product. But you can see those products on different lines. So maybe between different receipts. If you sell apples one time, you want to be able to sell them again. Okay, the next one is a shipment can contain many line items, but a line item can only be part of one shipment. Okay, so we sold the stuff, now we need to send it. So a line item this is an ER diagram that could definitely be reconfigured into a more efficient diagram to model the data for sure. Good thing it's not a real organization. Okay, so we can have one shipment only contains, or a line item can only be part of one shipment. Is that what it was? Shipment can contain many line items, but a line item, yes, can only be part of one shipment. Because if I order 5 apples, I'm not going to order 5 apples and 3 apples. I'm going to order 8 apples, right? So we shouldn't see that as separate line items, unless they're different types of apples. Okay. So there's that. And then here we have shipment can contain many line items. So we'll be able to send multiple items or multiple line items worth of products in a single shipment with this layout. Okay. Last is shippers and shipments. So let's say our company has to decide on a daily basis whether to use FedEx, UPS, or DHL, or the USPS. So we have a lot of different shippers. A shipper can ship many shipments, but a shipment can only be shipped by one shipper, right? So a shipper can ship many shipments. So a single shipper, we could assign a whole lot of our shipments to FedEx and a whole bunch to UPS, but we wouldn't take one package and say, okay, FedEx and UPS, deliver this package, right? So sometimes logic helps. In most situations, not in every situation, but in most situations. Okay, so a shipment can only go to one shipper. A shipper can handle many shipments. Okay. So one good thing about this example is I guess I didn't want to drive you insane, and I made every relationship a one-to-many relationship. So I'm just going to talk about the keys because it's following the exact same pattern 5 times. And then we'll talk about the number of tables, and then we'll be done with this. So in this, let's just assume for customers, there's customer ID, sales ID, line items, line item ID, etc., etc. All right. So if we had customer ID here, sales ID here, how would we represent that with foreign keys? Right? We have to take the primary key and use it as a foreign key somewhere else. And in a one-to-many, we always take the primary key from the one side and put it in the many. So customer ID would become a field, a foreign key field in sales. Sales ID, the primary key of sales, would become a foreign key in line items. The product ID, and you see what I'm doing, I'm just looking where the ones and the M's are, and I'm just copying the primary key down. So product ID goes into line items, shipments goes into line items, shipper's ID goes into shipments. So it's that simple. This also shows you how foreign keys are independent of each other. So in this case, we had the product ID, shipment ID, and sales ID all as foreign keys in line items. All that foreign key does is tells you when you're looking at that line item what the sale was, what products were in there, and in the line item, how many shipments there are, how many products, or what shipment, what product, and what sale was involved in that line item. All right, so how many tables does that make? So this is a question where you just need to understand what becomes a table. So we know that entities become a table. So we have 6 of those. Okay, so there's 6 tables at least there, and then we have to look for a many-to-many, because that will, each many-to-many relationship will add 1 table. So here we have a total of 6 tables. All right, so that is what I expected you to do. If you were close, you can go back and what I want you to do is fix it, and then I'm going to create an assignment here. We'll think of it together live, me and the one other person watching this. So if you're watching this and you can hear me, feel free to suggest anything you want for the exercise. So I am going to put, so remember, these extra exercises based off the quiz are extra credit so that you can recover some of the points lost, if you lost any points. If you didn't, then free bonus points for you. All right. New assignment. Assignment name cannot be blank. All right, well, I'm not trying to make it blank. Oh, there we go. So this is quiz. Oh, there it is. Okay, new assignment. Quiz. ERD quiz bonus. So to get the bonus, you do have to have the correct quiz questions on the quiz you submit. But I'm going to have you do some slight additional work so that I know you just didn't copy things from the video and submit that, because that would be a waste of time. But you're actually going to have to fix the problems so that you can actually do the exercise in the first place. So for part 3, so I'll just say it like this. For the first ER diagram, so I'll shorten that to, we'll do it like this. Entity relationship diagram. Add two entities and the required relationships. Make sure to label your relationships, foreign keys, and primary keys. I got this add-on for Grammarly because writing is not one of my strong suits here. So why not have a computer do it for you, right? Okay, and then let's do, basically I'm just gonna have you do the same thing for all three of the diagrams, because we had 1, 2, 3. Yep, okay. So is it one page? Oh, what's this page all about? I think I had to move that down to make it fit. Let's see. No, I think it'll fit in there. There we go. Well, I guess if I change it here, it's not going to change it for you guys anyway, so we'll say first, I just want to be clear here. Okay. For the second, there's only 3 ER diagrams in here. The first and the last one, I give you the diagram, the entities and the relationships at least. The middle one, you have to create the ER diagram first, but I went over how to do that in the video. So all you have to do to get the bonus points is fix mistakes on your quiz first, and then add in these 3 parts. If you do all that, then I will give you some bonus points towards that quiz, or yeah, towards the ER diagram quiz. All right, so there's not much else to say here. We were talking about, let me save this first. Well, last time we were talking about deciding field properties, so let's see when the next thing is due. Is October 12th. Okay, adding field oh, we still need to finish talking about field properties, so I might end up pushing this back again, and that way we'll have time to talk about it before it's due. Well, actually, if on the 12th, we'll definitely talk about it on the 12th, but if by then there are a lot of people that still haven't got it done, I'll push it back. Okay. So, I haven't actually used this app yet on Chrome. Let's see what it says. It says, should be a sentence. Capitalize this. This is so easy, or so, I like this. Okay, well these are going to have the same errors because I just copied and pasted them, but it's so easy to correct your grammar. This is the riveting part of the class. I'm not going to say anything else regarding the class, so if you don't want to watch this, I should have said that. Okay. Anyway, so I kind of just wrote down my, well, I guess it didn't detect this or tell me to put sentences at the end, but oh well. Oh, there we go. Maybe it'll, I wonder if it's representing these as different lines. I should do it like this. This is the, so I found out recently this is the proper way to do the plural of a abbreviation. The other form is the possessive. So oops. Apparently you can't do undo in here. I should have just edited the first one and then copied it over. Okay. So put the abbreviation and put a lowercase s after it. There we go. I'm going to copy this because I'm not sure if it's going to actually save this. All right, and then just to be more clear, work these as steps. So that it, you know, oh, come on. Okay, fine. It's going to make me do it this way. All right, and now, nope, okay, well, I swear they always change the way this stuff works while I'm trying to work on it. Yeah, here we go. Luckily, I know HTML. We'll just add a break tag in here. There we go. There we go. Nope, it's still going to do it that way. Okay. Why did it add in extra lists? Anyway, I guess you guys will just have to be able to see these all crammed together like that. Okay. Guess I could have just manually done it. And you will submit the completed file by next week. All right. So remember, if you need anything, you can contact me, and we can I can answer questions through email, or we can set up a Zoom meeting. Just let me know, and have a good day.